So after having the discussion about the primary and the candidate keys in SQL, and after realizing basically the significance of correctly specifying the constraints, we can move on to the next discussion, right? And the next discussion, let me put it on the board. So this was our last discussion. So now we can look at foreign keys and referential integrity, right? And referential integrity is a very important aspect that needs to be handled properly if you want the data in the database to be consistent, right? So let's first look at what is a foreign key. A foreign key is a set of fields in one relation that is used to refer to a tuple in another relation, right? So it's basically we are referring from a foreign key, and we are basically referring a primary key by using the concept of the foreign key. So what is the condition? The foreign key must correspond to primary key of the second relation, like a logical pointer. So like I said before, a foreign key refers to a primary key. For example, SID is a foreign key referring to students. So in the enroll table, the student ID is a foreign key which is referring to an SID, which is the primary key in students. Then we have the usual fields. So if all foreign key constraints are enforced, referential integrity is achieved. That is, no dangling references. What do we mean by dangling references? Dangling references basically mean that the reference is there, but the actual pointer to which that reference is accessing is not there. So can you name a data model without referential integrity? Right? It is basically links in HTML. Why it is a data model without referential integrity? Well, we might be referring to one link which is not present in the primary key. So let's now talk more about the foreign keys in SQL. So only students listed in the students relation should be allowed to enroll for courses, right? So that is our condition. Only those students that are properly registered, that is, they have their name in the students relation, should be allowed to enroll for courses, right? So how do we create such a relation? We execute create table enrolled, SID char20, CID char20, grade char2, primary key combination of SID and CID. And what is foreign key? SID references students. So this references clause in the enrolled relation is telling us that SID is basically referencing an SID in students. Or in other words, if an SID exists in students, then only that row is properly qualified to be entered into an enroll table. Or in simpler terms, whenever we would be inserting any row into this relation, the SID would be checked against the SID of students. So if the SID exists, then only that student can be entered in the enroll table. So if we look at the enroll table, we see that all SIDs that are here are present over here. So 53666 is over here, 53650 is over here, and 53688 is present as a primary key, but it has not been used as a foreign key in enrolled. What might be the causes? Student might not have taken a course, right? So how do we enforce referential integrity? So enforcing referential integrity is very important. So how do we do that? Consider students and enrolled. SID in enrolled is a foreign key that references students. So what do we mean by enforcing referential integrity? Well, we need to answer a couple of questions. what should be done if an enrolled tuple with a non-existent student ID is inserted, right? So if an SID does not exist in students and we are trying to enroll it in the enroll table, what should be done? We should not allow it. So such a tuple would be rejected. It won't be allowed to be entered. Again, what should be done if a student tuple is deleted? So that is again a important thing. So if we want to delete a student tuple, what should be done? We should also delete all enrolled tuples that refer to it. For example, if we are in a student relation and we are deleting a student ID 40,000. So if we are deleting the student ID 40,000, we should also delete all the entries in enrolled that have the SID 40,000. So that once the 40,000 primary key is deleted from students, we don't have any references of the foreign key in enrolled. So this can be one of the things. Or we can also disallow deletion of a student tuple that is referred to. What can we do? We can say no, we won't allow this student ID to be deleted from students because some foreign key references in enrolled are referring to this particular student ID in students. That is the second option. So in the first option, we delete all the enrolled tuples also, and then we delete the primary key in students. The second one is we don't allow the deletion of a primary key that is referred as a foreign key in enrolled. What is the third option? Set SID in enrolled tuples that refer to it to a default SID. So what we can say, we can have a default SID like null or like not used. So if we delete the primary key, we can set all the enrolled entries of the primary key to refer to that. For example, if we are deleting primary key 40,000, so every entry in enrolled that has the SID 40,000, what we would do, we would assign a default SID to such entries. So in SQL, we can set SID in enrolled tuples that refer to it to a default value null, denoting unknown or inapplicable. So if we delete in the third option, what you would do, when we'll delete the primary key of that SID from students, all the foreign key entries in enrolled, we would assign the SID to a value of null in the foreign key. And similar if primary key of students tuple is updated. What do we mean by that? For example, if we change 40,000 to 40,050 in the students, so we are updating the primary key. So we would change all foreign key references of 40,000 to 40,500 in enrolled as well. So we talked about all the measures we can take to refer or to ensure referential integrity. So how do we implement referential integrity in SQL? We can have different types of keywords that we can use, right? So it supports 4 options, right? So what we can have the 4 options. The first one is we can select default, which is no action. And what does no action mean? Delete and update is rejected. So what do we mean by that? Once the primary key has been created in the student's relation, we won't be able to delete it and we won't be able to update it. So as you can see, is no action flexible? No. Why? Because it's very limited. Once if we create a primary key, let's say we want to change it or we made a mistake, we won't be able to delete it and we won't be able to update it because it would be rejected. So no action usually is not used a lot in the SQL. So what is the next option? Cascade. And what does cascade means? Also delete all tuples that refer to the deleted tuple. So if we are deleting the primary key in students, all the foreign key references in enrolled that refer to this primary key would also be deleted. And what is the next option? We can use set null to set all foreign key referencing tuples to null. What do we mean by that? If we select this option and we delete an SID in students, for example, if we delete SID 10,000 from students, so all entries in enrolled that have SID 10,000 would be assigned a null value as the foreign key. Or we can also have a default value that is assigned. So for example, if we delete 10,000 SID from students, all the tuples of 10,000 in enrolled would be assigned a default value. So these are the options that we can have. On the right hand side, we have an example of the create table statement implementing referential integrity, right? So what is create table? Enrolled, SID, CID, grade. But what is the primary key in enrolled? The combination of SID and CID. And the foreign key SID, it means the SID field in enrolled is a foreign key which references the primary key table which is enrolled. And what are the conditions? On delete, cascade, on update, set default. So what do we mean by that? If we delete a primary key from students, all the foreign key references in this table enrolled would be deleted, and that is basically this option that we are having. Okay, and what do we mean by on update set default? If the primary key SID is updated in the students table, the entries in this enrolled table would be assigned a default value. So what do we mean when we implement both these referential integrity constraints? I repeat, if we delete the primary key in students, all the foreign key references in this enrolled table would be deleted. And if we delete a primary key SID in students, all the foreign key references of the old primary key in this enrolled table would be assigned a default value. So after having looked at all the integrity constraints, right, so we must be wondering, where do these integrity constraints come from, right? How do we know about them? From where in the world do these integrity constraints come from? So what is the answer? The answer is something I have been saying for the past 2 lectures or so, that integrity constraints are based upon the semantics of the real world enterprise that is being described in the database relations, right? So all these integrity constraints are coming from the real world data, or the data of the organization and the forms that are being handled in the organization, of which we are making the database. So it's nothing from heavens coming to us, it's just real world situation, right? So we can check a database instance to see if an integrity constraint is violated, but we can never infer that an integrity constraint is true by looking at an instance. So we can check a database instance to see if an integrity constraint is violated. So checking of violation is easy, but checking of correctness is very difficult. So we should not go into much detail, but we should just realize that we check and we catch the violations as they occur, and that helps in making the data and data consistent, and that helps in preventing the wrong or stupid data to be entering in our database. So an integrity constraint is a statement about all possible instances that can be there. So for example, we know that name is not a key, but the assertion that SID is a key is given to us. What do we mean by that? We can look at the student relation and the data that is there to find out that name is not a primary key. Why is not name a primary key? Because name is repeating in the student's relation, right? But we have the assertion that the student ID is a key, and that may be given to us by the organization, right? Just for example, if we are working in the UIT, right, in UIT, the authority would tell us that student ID or roll number is the primary key of a student. So key and foreign key integrity constraints are the most common. Some more general integrity constraints are supported too, right? So some integrity constraints can be related to the type of the data that is being entered in the database. So that are also supported. So now we can look at a logical database design, and now we are looking at the conversion from the ER to the relational type. Okay. So first we'll look at the entity sets to tables. So employees entity set we have here, which has the fields SSN, name and lot. And SSN is underlined because it's a primary key. So how do we enter it? We say create table employees, this and this, and we also specify that SSN is the primary key over here. So that is the definition of employees. So now when we are translating relationship sets to tables, so in translating a relationship set to a relation, attributes of the relation must include keys for each participating entity set as foreign keys. And what is this? This is the set of attributes forms a super key for a relation. And we also have all descriptive attributes.